Welcome everybody to this Lightboard session where we're going to learn a little bit more about vSAN. In this particular session, we're going to look at some of the different data placement schemes that we have in vSAN and look and help you better understand the respective space efficiency that they have around it.
So starting at the top here, we'll start with what has been the default within the original storage architecture for a very long time. And this is RAID 1. And this is a simple mirror to where data is mirrored between components on two different hosts. And then you have a witness component that's used to provide quorum for split brain protection. This requires a minimum of 3 hosts, or in the cases of a 2-host cluster, there's a witness component that goes on a dedicated witness appliance that runs elsewhere. This was historically our smallest scaling point, and if you had 3 hosts within the original storage architecture prior to vSphere 8, this was your only choice up until you got to 4 hosts. The new offering that's available within the Express storage architecture is a new RAID 5 design that is a 2+1. So there's a data parity component. Now this is rather nice because previously you had to pay that 2x capacity overhead until you got to a minimum of 4 hosts. Now we can reduce that capacity overhead to only a 1.5x. So our 100 gigabyte VMDK, where the data fully inflated out, is going to be 150 gigabytes of raw capacity consumed. The ESA also does some things to make this perform much like the old RAID 1, so we get to have our cake and eat it too here a bit. Now the next is within the original storage architecture, the original RAID 5 design we had, which was a 3+1. So we have data parity in a diagonal manner. This did have a little bit of a performance hit because we have a read-write cycle that was tied to this. These were, again, some of the improvements we tried to mitigate with the new ESA design. From a capacity overhead, this specific design, your multiplier from capacity is a 1.33. And so because we've got that data parity, that's what we have. And so, if you wanted to have the ability to tolerate a failure and things like that, you might have even added a 5th host. Now, from a RAID 5 perspective, with the ESA, you may have looked and said, well, this is more capacity overhead than the old system. Why do we move to something less efficient? Well, we actually have a dynamic system. So as that cluster grows and you add enough hosts, we actually have a 4+1 design. And this actually has a 1.25x capacity overhead. So again, 100 gigabyte VMDK is going to be 125 gigabytes under this. So at scale, this is actually going to get us some capacity improvements, in addition to the other capacity improvements from no longer needing cache devices and things like that have been done, better compression, other data compaction that makes the Express storage architecture often more cost efficient for net new designs.
Yeah, John, I think what you mentioned there is really important for everybody to recognize that is so unique about the Express storage architecture. What he mentioned there about the RAID 5 level of failure to tolerate of 1 option is there's only one storage policy for RAID 5. But vSAN is smart enough to figure out, based off of the size of your cluster, the number of hosts in your cluster, it's either going to use a 4+1 data placement scheme, or it's going to use a 2+1 data placement scheme. It's going to vary a little bit in the space efficiency, but what this gives you is deterministic space efficiency with just a 3-node cluster, which is absolutely a fantastic option for many of our customers that have a smaller cluster size.
Now, these designs all are based around being able to support a single failure to tolerate of a single fault domain, in this case, a host being the default. As we go up to the ability to tolerate the failure of 2 failure domains, 2 hosts by default, we have a RAID 1 type design. This is not commonly chosen for reasons that'll become pretty obvious. This was part of the original storage architecture. And this has a 3x overhead. You're basically building a triple mirror and then 2 different witness components. There are some customers who use this for very mission critical things. But this is very much a corner case just because of the sheer capacity cost. Now, that did have a 5-host minimum. Now, when we get to 6 hosts, we can perform the RAID 6 design. And this is similar in terms of how it works on both architectures. From a capacity overhead, this is a 1.5x, so our 100 gigabytes of data, once written, is going to take 150 gigabytes of raw. This uses a 4 data 2 parity design.
So we've thrown a lot at you in this Lightboard session. If you'd like to learn more about the data placement schemes that are available to you, feel free to jump out to core.vmware.com, where you can learn about all of these options and what works best for your environment. Thank you very much.